All right, we're going to talk a little bit about finding factor pairs, which more specifically leads to finding factors. So of course we're going to have to get a few things. We've got to know some terminology. So the first one I have for you here is a multiple. It's the product of a given whole number and another whole number. And you might be sitting there thinking, well, I'm not really sure exactly what that is. Let me show you very, very simply. Just for examples, let's do the multiples of 2. So if I was doing the multiples of 2 here, then what I would do is I would say, well, I can get 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and it just goes on and on and on and on and on. So every multiple, every one that I would come to in this list, so all of these right here are multiples of 2. Okay, so very simple. These are basically the answers that you're memorizing to those multiplication facts you've been doing. Then we've got factor. And the definition I have here is one of the numbers multiplied by another number to get a product. Again, that might seem a little hazy until I do something like this. If I find, let's do 7 times 8, well, we know that equals to 56. So 56 is the product. And 7 and 8 are both factors of that product. So these numbers right here in that multiplication problem are the factors. So you've been dealing with factors and products all along. Okay, so move. Some more terminology. I'm throwing these in because you're going to hear these quite a bit, and I think that the more you hear them, the easier it's going to be. Composite number is a number with 3 or more factors. Again, very, very simple. So let me throw a composite number in like, well, let's just do 8. Okay, whenever you're naming factors, you always go in order. So I always start with 1. So I can do 1 times 8. So 1 and 8 are both factors of 8. I can do 2 times 4. So 2 and 4 are both factors of 8. So my factors of 8, in fact, that's all of them right there, are 1, 2, 4, and 8. Those are the factors of 8. And this makes 8 a composite number because it has 4 factors. It just has to have 3 or more. So the place that you would, one place that you would find 3 factors would be a number like 9, where you have 1 times 9 and 3 times 3. Well, see, you're not going to count both those 3's. You're just counting one of them. So it's 1, 3, and 9. So it meets that minimum of 3. So any number that has 3 or more factors. So we come to the opposite of a composite number, a prime number. It's a number with only 2 factors, 1 and itself. So this would be a number like 3, because I can do 1 times 3 to get 3, and that's it. Interesting side note is 2. I can do 1 times 2, and that's it. So 2 is a prime number also, even though it's even. And that leads to an interesting little bit of information that 2 is the only even prime number. A lot of people look at this and they think, oh, well, every even number is composite and every odd number is prime. Well, 2 proves that wrong. 2 is even, and it's a prime number. Prime numbers have really not much to do with even and odd. It has to do with how many factors the number has. Okay. Oh, one other interesting little tidbit. 1 is not prime or composite because its only factor is itself. So it's only got one factor. So it's not prime or composite. So moving on to our next slide. So if I was looking to test if a number had 2 as a factor, let's just look at the multiples of 2. They are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and of course we could keep going. And you might look at those and say, wow, those are all even numbers. Even numbers end in 0, 2, 4, 6, or 8, just like all of these do. And that is it. Every even number has 2 as a factor. So even if we got down to massive numbers, let's say I did 51,394, to tell if a number is even or odd, you only look at the last digit. That 4 right there tells me this number is even, and so it could be evenly divided by 2. It has 2 as a factor. Pretty cool. Let's look at again to the next slide. Okay, 3 is a bit more tricky, but it's actually kind of also a bit more fun. So we've got 3, 6, 9, 12, 15, 18, 21, 24, 27. And I guess I could fit, let's fit 30 in there. Let's fit 30. Proves a point. Okay. Just looking at these, there's a mixture of even and odd numbers, so we can't go off of that. But let's take this into consideration. Let's look at all the single digit numbers are easy enough. That's pretty easy. But let's look at this. What if I took this 12, if I add the 1 and the 2 together, what do I get? I get 3. What if I add the 1 and the 5 from the 15? I get 6. What if I add the 1 and the 8 together? I get 9. Wow. What if I add the 2 and the 1 here together? Well, I get 3 again. What if I add the 2 and the 4 together? I get 6. How about this? Well, I get 9. Are you starting to see a pattern? Any number that has 3 as a factor, if you add the digits, will add up to a multiple of 3. If you know 3, 6, 9, 12, 15, 18, that usually makes it through. I could even go so far and put down, let's put down 378. So let's see if we can tell if this number has 3 as a factor. Well, 7 plus 3 is 10, plus 8 is 18. So all of these numbers adding together make 18. Yep, it's got 3 as a factor because it added this right here, this 18 is a multiple of 3. There it is right there. Okay, so let's go to a even larger number. Let's go to 1008. You might say, wow, that's pretty tough, but it's actually not. If I do 1 plus 0 plus 0 plus 8, well, I'm basically adding 1 plus 8, and I'm getting 9. Well, guess what? 9 is a multiple of 3, so this number is evenly divisible by 3, meaning it has 3 as a factor. Okay, final factor test. This one is an easy one. Multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, and 45. Okay, if you just look at these, you'll see in the ones place of every single one of them is a 5 or a 0. Every single one of them. So if I were to write a number like 1005, well, then right here, that 5 is telling you, it's in the ones place, that that is evenly divisible by 5. Now, if I did, let's say, 153, in the ones place is a 3. So that is not evenly divisible by 5, so it does not have 5 as a factor. The 5 has to be in the ones place, or it has to have a 0 in the ones place. So let's say like 970. It's got a 0 in the ones place right there, and it's telling you, hey, I'm divisible by 5. Now, of course, all this has to be combined together when we're finding factors of numbers. So let's see all this together in action. What would this look like if I were trying to find all of the whole number factors of 30? Whole numbers just being the numbers we normally deal with, not decimals. So the way that I do it is this. I start off with my number I'm looking for the factors, and I put it under a line. Now, if you go in order, you will know when you have reached the end. If you don't go in order, it's almost impossible. So I always start with the first number, 1. That's easy. 1 times the number itself always equals that number. So the second number is 2. Remember our check? 30 is even. So I know 2 has to work. So let's say I'm not sure what I'd multiply. I'm not sure what the other factor is. So then I simply take my 30, divide it by 2. Not a complicated problem to do. Okay, looky there. It told me right there. It's 2 times 15. Okay, next number I check is 3. Remember my check for 3? Add 3 plus 0, I get 3. So 3 is a factor. And I happen to know my multiplication facts, 3 times 10. Now if you notice on the left-hand side, we're getting larger. On the right-hand side, we're getting smaller, which is how this process works. Okay, so next number I would check is 4. Since I know my multiplication facts, I know that nothing times 4 is 30. 4 times 7 is 28. That's close. 4 times 8 is 32. That's close, but none of them are right on. So now I skip to 5. This number has a 0 in the ones place. 30 has a 0 in the ones place. That's telling me, hey, I am evenly divisible by 5. And since I know my multiplication facts, I know that 5 times 6 is 30. My next number to check would be 6. And look, I've already got it. So that right there tells me I'm finished. I found all the factors. And if I want to write them in order, I just need to go down this side and up this side, and I'll have them all written in order from least to greatest, which is what you have to do when you're working problems like this. So they are in order: a 1, 2, 3, 5, going up the other side, 6, 10, 15, and 30. So those right there are all the numbers that are factors of 30. I can multiply them and get factors of 30. One more interesting thing, if you line them up like this, you can do what's called a factor rainbow. 1 times 30, 2 times 15, 3 times 10, 5 times 6. See the little rainbow? There it is.